Good morning, students. Our new topic for today is the properties and uses of ammonia in the topic of acid, basis, and salt in the subject of chemistry O levels. So concentrate yourself. A lot of concepts will be involved in this topic. So alert your mind. So we are going to start now. Properties and uses of ammonia. Ammonia is a common gas given off from rotting animal manure. So this is a gas which is obtained by rotting of the animal manure. The manufacture of the ammonia, industrial level. Ammonia is manufactured from nitrogen and hydrogen by the Haber process. So the first thing that you have to remember, the process is called Haber process, and definitely NH3 is obtained by the by combination of N and H, that is nitrogen and hydrogen. Nitrogen is obtained from the distillation of the liquid air. So this is the process by which we will obtain nitrogen. So read it again, obtained from the distillation of the liquid air. Okay, now hydrogen is left. So hydrogen is obtained from one of these two methods. So it can be obtained by steam reforming of the natural gas. So look now, this is natural gas, this is steam reforming of the natural gas. So carbon dioxide and hydrogen will be obtained. So this is one way. Or cracking of the petroleum fraction. So C to H6 forms C to H4 and hydrogen gas. So one of these two methods will be used for the manufacturing of the hydrogen, and nitrogen is obtained from the distillation of the liquid air. So now two things are obtained. So a mixture of the 1 volume of the nitrogen and 3 volumes of the hydrogen are reacted according to the equation below. So N2 plus 3H2 forms 2NH3, and in this process 92 kilojoule of per mole energy is released into the environment. So this is exothermic reaction. The reaction used in the Haber process is a reversible reaction. So this is another point to remember. This reaction is called a reversible reaction because in which forward reaction and backward reaction takes place. So this is a diagram which is actually showing the industrial manufacture of the ammonia. So here is a video that will make your concepts more clear.
Industrial preparation of ammonia. Industrially, ammonia is manufactured by Haber's process. Reactants: 1 volume nitrogen gas and 3 volumes of hydrogen. Temperature.
So this is the first thing, 1 volume of the nitrogen gas and 3 volume of the hydrogen gas. Temperature will be 450 to 500 degrees C, pressure 2 to 900 atmosphere.
450 to 500 degrees centigrade. Pressure 200 to 900 atmospheres. Catalyst: iron. Promoter: molybdenum. Reaction: N2 plus 3H2 gives 2NH3.
So this is the industrial manufacture of the ammonia. Okay, moving further. So this is a diagram, that is flow diagram of the Haber process. Okay, cost of making 1 ton of the ammonia gas. So almost $343 are used for making 1 ton of the ammonia gas. Okay, reaction conditions in Haber process which you have seen in the video are temperature almost 500 degrees C, pressure to 50 atmosphere, catalyst finely divided iron. The conditions chosen above represent the optimum conditions. So optimum conditions are actually most suitable conditions under which maximum of the product can be produced. So these are called optimum conditions for producing a reasonable amount of the ammonia in a reasonable period of time. Since the reaction is exothermic, a lower temperature would favor a shift in the position of the equilibrium to the right to increase the yield of the ammonia, because exothermic reaction is a reaction in which heat is given out. So if we make an arrangement in which we can decrease the temperature of the environment, that will favor the reaction, so maximum of the output can be produced. The addition of a catalyst would speed up the reaction carried out at low temperature. Increasing pressure favors the forward reaction, as 4 moles of the reactant gases are changed into 2 moles of the product gases. So look now, because in the reaction you can see 4 moles of the reactants are there and 2 moles of the products are there. So when the moles of the reactants are greater than the moles of the product, so according to Le-Chatelier's principle, increasing pressure will favor the reaction, and equilibrium reaction will move towards the right, and the yield of the product will be increased. Okay, next topic that we are going to read is the laboratory preparation of the ammonia. Ammonia can be prepared by heating a mixture of the ammonium salt and an alkali. The alkali is used to displace ammonia from its ammonium salt, and here is a reaction. So look now, ammonium chloride plus NaOH. So ammonia can be prepared by heating a mixture of the ammonium salt and an alkali. So look here, it is an alkali and here is ammonium salt. So when they react with each other, salt, ammonia and water are produced. The ammonia gas liberated can be dried with calcium oxide. Ammonium fertilizers such as ammonium phosphate will lose their nitrogen if the farmer adds calcium hydroxide to the soil. So this is the method through which farmers separate nitrogen from their compound. So nitrogen is important for the plant growth. Calcium hydroxide displaces ammonia from the ammonium fertilizer. So look now, calcium hydroxide. So here is calcium hydroxide displaces ammonia from the ammonium fertilizer. So here is ammonium fertilizer, that is ammonium phosphate. So the product is calcium phosphate, ammonia and water. So ammonia is produced. So this is laboratory preparation of the ammonia. Here is a video.
Preparation of ammonia. A test tube containing a mixture of ammonium chloride and calcium hydroxide is heated. After some time, ammonia gas is evolved. The gas is passed through the lime tower, where the moisture is removed. Drying is necessary because water vapor is one of the products formed. Ammonia gas, being highly soluble in water, has to be dried quickly to prevent it from dissolving. Dry ammonia gas, being lighter than air, is collected in the inverted gas jar by the downward displacement of air. Calcium chloride is left behind in the test tube. A moist red litmus paper is used to check for the presence of ammonia in the jar. The red litmus paper turns blue because ammonia is basic.
So this is the method that is adopted in the laboratory for the preparation of the ammonia, and ammonia test was also done. Red litmus paper turned into blue. Okay, here we are going to read another topic, that is testing of the ammonia. Ammonia turns red litmus blue and does not burn in air when a lighted splint is applied. So when we light a splint and bring it into the ammonia gas, the lighted splint will get off. This is one test. And second is the ammonia gas turns a red litmus paper blue. So these are two tests for checking ammonia gas. Dense white fumes of the ammonium chloride are formed when ammonia gas comes into contact with hydrogen chloride gas, the stopper from a bottle of the concentrated hydrochloric acid. So this is a reaction. So when okay, here is a figure that will show that a white fumes of the here it is dense white fumes of the ammonium chloride are formed. So look now, here is ammonia gas and here is hydrogen chloride gas. When they combine with each other, white dense fumes of the ammonium chloride will be produced. Next, we are going to read the properties of the ammonia. Ammonia is a colorless gas with a pungent and characteristic odor smelling salts. It turns red litmus blue and is less dense than air. Solubility in water. Ammonia dissolves very readily in cold water to form ammonia solution. This is sometimes called ammonium hydroxide, that is NH4OH. This solution is alkaline, and here is the reaction. The solubility of the ammonia in water can be demonstrated by the fountain experiment. So this is another very important question. This comes in the paper as a short question, as a fountain experiment, because ammonia gas is dissolved in water. So when it is dissolved in water, the water actually pushes into the tube and that make a shower. So this is called this test. So look now, fountain experiment. A dry flask is filled with dry ammonia. So look now, a dry flask is filled with dry ammonia and set up as shown below. Here is the setup. The end of the tube is dipped into water. So this is the end of the tube which is dipped into the water. The water level rises in the tube as the ammonia dissolves and the water fountains into the flask. So here will create a fountain because the ammonia gas will be dissolved in water. Next thing that we are going to read is the reaction with acids. Ammonia gas is absorbed by acids to form ammonium salt. So here are reactions of ammonia with different acids that will make salt. So NH3 plus ACl form NH4Cl. NH3 plus HNO3 forms NH4NO3. NH3 plus H2SO4 forms NH4 twice SO4. Next reaction that we are going to read is the combustion of the ammonia. Ammonia does not burn in air, but it burns in oxygen or air enriched with oxygen. So 4NH3 plus 3O2 forms 2N2 plus 6H2O. So when ammonia burns in plentiful of the oxygen, nitrogen gas and water are produced. Substances do not burn in ammonia gas. It is possible to oxidize ammonia with oxygen in the presence of a heated platinum catalyst to form nitrogen monoxide. A heated platinum wire glows brightly in a mixture of the ammonia and oxygen because this reaction is very exothermic. Because this is very exothermic, heat is given out. That's why when platinum catalyst to form nitrogen monoxide, a heated platinum wire glows brightly in a mixture of the ammonia and oxygen because this reaction is very exothermic. This is the basis of the industrial manufacture of the nitric acid from ammonia. Ammonia as a reducing agent. When ammonia gas is passed over heated copper oxide, the ammonia is oxidized to nitrogen and copper oxide. So here is the reaction. So when ammonia is reacted with copper oxide, copper, water and nitrogen is obtained. A similar reaction takes place with oxides of the lead and iron. This experiment can be used to demonstrate that ammonia contains nitrogen. When chlorine and ammonia gases are mixed, so look now, Chlorine is reduced to hydrogen chloride. So hydrogen chloride will be produced because chlorine will be reduced to ACl. However, a further reaction takes place and ammonia plus ACl combines to form ammonium chloride. Adding these two quantities equations together gives the equation. So these two equations will combine and will form this equation. Okay, the next thing that we are going to read is the ammonium compound. Ammonium compounds contain the ammonium ion, that is NH4 plus. This ion is produced when hydrogen ion H plus is bonded to the spare pair of the electrons on the nitrogen atom in the ammonia molecule, forming coordinate bond. So when NH3 and H plus combines, so they will make NH4 plus. So ammonium ion will be produced. Although ammonium compounds contain no metal ions, they are very similar to the corresponding alkali metals compounds in many ways. Ammonium chloride and sodium chloride are both colorless crystalline solids that dissolve in water. Ammonia solution, ammonium hydroxide, is an important alkali and is a source of all ammonium compounds. So, whenever we are going to form ammonium compounds, so ammonium hydroxide is a very important reactant. It precipitates metal hydroxide from solutions of the certain metal salts. So here are the reactions: ammonium hydroxide with iron chloride. So here are the reactions. In the case of the copper hydroxide precipitation, the copper hydroxide precipitate re-dissolves and forms a deep blue solution containing the complex tetraamine copper ion. The following general remarks about ammonium compounds are worth remembering. So these are very important points which you have to learn. Most ammonium salts are white crystalline solids. Exception: ammonium dichromate is orange. All ammonium salts are soluble in water. All ammonium salts liberate ammonia gas when heated with an alkali. Ammonium compounds are not very stable thermally. They sublime or decompose on heating. Ammonium chloride and ammonium carbonate sublime. Sublime is a process in which a solid is directly converted into gas, or a gas is directly converted into a solid without passing through the liquid state. Ammonium nitrate, ammonium nitrite and ammonium dichromate decomposes on heating. They are used as ammonium nitrate, important in explosives. For example, amatol is a mixture of ammonium nitrate and TNT. As a fertilizer mixed with chalk, nitro chalk. Ammonium carbonate is used in smelling salts. Ammonium bromide is used in photography. And ammonium phosphate is used as a fertilizers. So these are the use of some ammonium compounds. Next, we are going to read the uses of the ammonia. Ammonia is used to make fertilizers, nitric acid, explosives, nylon. Nitrogenous fertilizers are needed to promote plant growth and crop yield. The alkalinity of the ammonia solution makes it a useful cleaner for greasy surfaces such as cooker or windows. Ammonia gas is a hard stimulant. It also unblocks the air passages in a blocked up nose. It is used in making plastics. Two common solid fertilizers are ammonium nitrate and ammonium sulfate. Ammonium nitrate is made by reacting ammonia with a nitric acid. Here is the reaction. NH3 plus HNO3 forms NH4NO3. And ammonium sulfate is made by reacting ammonia with sulfuric acid. Reaction is 2NH3 plus H2SO4 forms NH4 twice SO4. NPK fertilizers contain three essential elements needed by plants for healthy growth, that is nitrogen, phosphorus and potassium. So these three are very important for the healthy growth of the plants. Nitrogen is needed to make proteins, phosphorus is needed to grow good roots, and potassium is needed to carry out photosynthesis. Ammonia gas is used as a refrigerating liquid. Ammonia is used for washing and cleaning household ammonia. The next thing that we are going to read is the nitrogen content in fertilizers. The nitrogen content in chemical fertilizers can be determined by calculating percentage masses. An example is here. A very short question come of this type always come in the paper. So ammonium compound will be given and you will be required to find the percentage mass of the nitrogen out of it. So look now the method. For example, ammonium nitrate is given. First we will find the molar mass of the ammonium nitrate. So there are 2 nitrogen atoms, so 2 into 14 plus 4 hydrogen atoms, so 4 into 1, and oxygen atoms are there 3, so 3 into 16. Solve it on the calculator. So 80 is the molar mass of the ammonium nitrate. Now the percentage mass of the nitrogen. So actually there are 2 nitrogen atoms. So 2 into 14 will be placed in numerator. Total will be placed in denominator. Multiply by 100%. You will solve it on the calculator. So this is the answer. So it shows that nitrogen is 35% present in ammonium nitrate. Another example is here. That is ammonium sulfate, and you people will do it by yourself. Here is the solution. The same method will be followed. The next thing that we are going to read is nitrates. All nitrates are soluble in water. The ease of the decomposition of the metal nitrates when heated is related to the position of the metal in the reactivity series. The lower the metal in the series, the more readily and completely the nitrate of that metal decomposes. So this is the very important point. The lower the metal in this series, the more readily and completely the nitrate of that metal decomposes. Table below summarizes the action of the heat of on some nitrates. So here are some nitrates which are given. So potassium nitrate, color will be white. Equation is potassium nitrate will form KNO2, that is potassium nitrite plus O2. Color of the solid residue will be white. So these are some reactions. Write it down in your copies and learn it. Next, we are going to read the test for the nitrate. There are 2 tests that can be used to test for a nitrate in solution. An equal volume of the iron sulfate solution acidified with dilute sulfuric acid is added to a suspected nitrate in a test tube. So equal volume of the iron sulfate solution will be added to suspected nitrate in the test tube. Concentrated sulfuric acid is poured carefully down the inside of the test tube so that it forms a separate sulfuric acid layer below the aqueous layer. This is because concentrated sulfuric acid is denser than water aqueous solution. If a nitrate is present, a brown ring forms at the junction of the 2 layers. So this is the sign that if nitrate is present, so a brown ring will be formed. The brown substance is FeSO4. So this is one test for checking the nitrate. And other test is sodium hydroxide solution is added to a suspected nitrate. So sodium hydroxide will be added and aluminium powder is added. Okay, this is an alloy containing aluminium that reacts more slowly than pure aluminium. The mixture is warmed and hydrogen is produced. If a suspected nitrate is added, it will be reduced to ammonia gas. This will turn red litmus paper blue. So this will be, finally we will check. So look now again, sodium hydroxide will be added to suspected nitrate and aluminium powder is added. The mixture is warmed and hydrogen gas is produced. If suspected nitrate is added, it will reduce to ammonia gas. Then we will put red litmus paper into the jar. If it turns blue, so this will be the sign that nitrate is present. So this is the second test. Next thing that we are going to read is the nitrate pollution. Excessive use of the nitrates, phosphates, and potassium fertilizers causes a water pollution problem called eutrophication. This is very important topic. This frequently come in the paper. That is called nitrate pollution. These soluble nitrates, phosphates, and potassium dissolves in rainwater and are leached from the soil into the rivers and streams. So when farmers mix these NPK fertilizers into their farms, so they mixed with water and leached into the ground and go into the rivers and lakes. The algae population is able to grow very rapidly because of this. The death of these algae provides a very rich food supply for organisms to decompose. So because of this rich food supply, the organisms gathered there. The decomposition of the algae uses up large quantities of the oxygen from the water. So when algae decompose, the oxygen will be used from the water. The aquatic animals and plants die as they are deprived of the much needed oxygen. Their dead bodies are further decomposed and the situation gets worse. So this is nitrate pollution. Highly soluble nitrate and nitrite fertilizers can leach into the reservoir that supply our drinking water. So look here, here is another problem of excessive use of NPK fertilizers. So when water dissolves NPK leached into the ground, and that water actually come into the reservoirs from where we use drinking water. So look now. The increased level of the nitrates in the water supply can cause health problems. Bacteria in the guts of the infants can convert nitrates to nitrites. Nitrite disrupts the ability of the hemoglobin molecules to carry oxygen. So this can be very much harmful for the infants because the nitrite actually affect the ability of the hemoglobin to absorb oxygen. Rapid growth in plant life has several effects. The river or lake becomes choked with plants. So these are the effects of the nitrate pollution. Sunlight cannot penetrate to lower level plants and these die. Dead plants decay by bacterial action. Bacteria removes oxygen from the water as they consume the dead plants. When the oxygen is gone, other bacteria take over the produce rotten smell. Hydrogen sulfide. So hydrogen sulfide is the gas which actually produce a very bad smell as they finish the decay process. Without oxygen, animal life is threatened and plants cease to grow. The river or lake becomes eutrophied, dead, because all the living organisms will be dead because sunlight is unable to penetrate to the lower levels of the water. Oxygen has been used up by the decomposition of the algae and decomposition of the living things that have become dead. So the lake will become dead. Next thing that we are going to read is laboratory manufacture of the nitric acid. In the laboratory, nitric acid is prepared by heating mixture of potassium nitrate and concentrated sulfuric acid. The nitric acid distills over because it is more volatile. The experiment must be carried out in all glass apparatus because, so this is very important point. This question comes normally in the MCQs paper because the manufacture of the nitric acid should be carried out in glass apparatus because nitric acid vapors attacks rubber and cork. The cold water condenses the nitric acid vapor. The nitric acid produced should be colorless, but it is often yellow in color due to partial decomposition. The yellow color can be removed by bubbling air through the acid. So this is the method to remove the yellow color. So here is the figure that is actually used in laboratory. So this is the setup. Next we are going to read is the industrial manufacture of the nitric acid. An industrial chemist called Ostwald invented a way of making nitric acid from ammonia and air and water. A flow diagram of this process is shown below. So here is the flow diagram. Ammonia and air will be reacted to form the mixture of the gases is compressed to 2 atmosphere. The mixture of the gases is passed over a catalyst and alloy of the platinum and rhodium at 900 degrees C. Nitrogen monoxide and steam are formed. The mixture is cooled. Nitrogen monoxide reacts with air to form nitrogen dioxide. Water trickles down a tar packed with glass balls. Nitrogen dioxide and air pass up the tar. As they meet, water and nitrogen dioxide and oxygen react to form nitric acid. The industrial plant must be made of acid-resisting steel. So nitric acid will be made. Okay. And here are the stages. So the stage 2 will be ammonia and oxygen will be reacted. Nitrogen monoxide will be formed. This nitrogen monoxide will react with oxygen to form nitrogen dioxide. And this nitrogen dioxide will react with atmospheric oxygen to form nitric acid. Some properties of the concentrated nitric acid are shown below. Used in the manufacture of the explosive, for example, nitrogen glycerine, that is dynamite, and TNT. Used in the manufacture of the fertilizers, for example, nitrame, ammonium nitrate. Now we are going to read the reactions of the dilute nitric acid. So when dilute nitric acid reacts with metals, including the less reactive metals, for example, copper, so it forms metal nitrate and nitrogen dioxide and water. So here are the products. When dilute nitric acid HNO3 react with alkalis, for example NaOH, NH3, it forms metal nitrate or ammonium nitrate plus water, and here are the products. When dilute nitric acid react with bases, for example CaO, ZNO, It forms metal nitrate plus water. So here are the products. When dilute nitric acid HNO3 reacts with carbonates, for example calcium carbonate, it forms metal nitrate, water and carbon dioxide. And here are the products. Also, it forms an acidic solution in water and will turn pH paper red. Reaction of the concentrated nitric acid. Concentrated nitric acid is a powerful oxidizing agent. It will oxidize both metals and non-metals. It will oxidize carbon to carbon dioxide. So here is the reaction. So HNO3 oxidizes carbon to carbon dioxide. It will oxidize copper to copper nitrate. So here is the reaction. Okay, the next thing that we are going to read is the checklist. That is some definitions. The first definition is nitrogen fixation. So what is nitrogen fixation? So concentrate the direct use of the atmospheric nitrogen in the formation of the important compounds of the nitrogen. So this is called nitrogen fixation, in which we use directly from the atmosphere the nitrogen. Bacteria present in the root nodules of these certain plants are able to take nitrogen directly from the atmosphere to form essential protein molecules. So this is called nitrogen fixation. Next is nitrogen cycle, the system by which nitrogen and its compounds both in the air and in the soil are interchanged. So this is called nitrogen cycle. Next is optimum temperature, a compromised temperature used in the industry to ensure that the yield of the product and the rate at which it is produced make the process as economical as possible. And the last thing that we are going to do in this topic is artificial fertilizer, a substance added to the soil to increase the amount of the elements such as nitrogen, potassium and phosphorus. This enables crops grown in the soil to grow more healthy and to produce higher yield.